We're going to review quickly some of the basic octave and start some new, more advanced octave. All right, so let's start with the basic for loop. So if you take a look at the octave notes, these are the octave notes for Math 220, and you can see we start pretty basic stuff we learned in Calc 1 and 2. And loops is one of the more serious things we learned. So let's take a look at some basic loops. So let's try this one out. So I'm going to copy it and simply try to paste it into an octave editor. So you can ignore the first two lines. Just always put them in your program. It's just a technical reason to have them. Clear refreshes all the variable names. All right. So we have our for loop right here, and let's run it. So let me save it. Go to a directory, and just call it, maybe test01.m. Add directory to load path. Okay. So you can execute it over here in the command window. If you hit the up arrow, you can get the previous commands. All right, what happened? Well, here are the variables. So A looks a little small. Let me see if I can make that a little bigger. So edit preferences. I'm not sure. All right, so A is 19 and I is 5. So what happens? A starts at 14, and as this loop progresses, it does the loop 5 times. I starts at 1, goes to 5. So let's see what's happening. Let's display A as we go along. All right, and in order to get some more info, we could say value of A doesn't like that. Okay. All right, so this is the value of A. So as the loop runs, we're printing A so we can see what happens. So A starts out at 14. Then when I goes, then A adds 1 to A. So we add 1 to A, and A will become 15. Then we go back to here. Now I is equal to 2. Displays A at 15. Adds 1 more to A. Now makes I equal to 3. Displays A. Now it's 16. So maybe we can make it a little bit better. We could say display I, and then we'll display the value of I. And we'll display A, and then the value of A. So let's try this one out. All right, so I is 1. A is 14. Okay, then I becomes 2, A is 15. Now, A was updated over here, so when I is equal to 1, it was updated in this loop, but we didn't print out the new value of A right here. We printed out the value of A when we got back in the next iteration. So let's say we put this A equals A plus 1 right in the beginning here. Let's try it right there. See what happens. I1, A is 15. See, right away, A has been updated. I is 2, I is 16. Alright, so that's a very basic for loop. Let's write a for loop to add up the first 1,000 numbers. So this is a very basic, problem. Alright, so S equals 0 for I equals 1 to 1,000. S equals S plus I, and for display S. Alright, so there we go. The sum of the first 1,000 numbers is 500,500. How about the first 1,000 squares? Well, that's really easy. You just change the I to an I squared. So when I is 1, you're adding 1 squared. When I is 2, you're adding to the previous sum 2 squared. So let's do this one. Let's first see if it works. All right, looks good. Let's do it with smaller numbers and see what's going on. So we're going to display I, and then we're going to display S. Alright, so I is 1, S is 1. I is 2, S is 5. Well, we just added 2 squared, which is 4. I squared. I is 3, S is 14. So you can incrementally see what's happening in this for loop. For loops don't get much more complicated than this. There are some other options like you can skip values. So let's see what this does. So like this. Put the 2 here and the 10 here. So notice what it did is it started at 1 and then it skipped values to get to 5, 7, 9. So that's how you can get the odd square. So that would be the sum of the first squares where you're adding the numbers less than 10. Okay, so that's the basic idea of a for loop. Let's recall an array. So let x equal zeros, 1, 5. Okay, so 1, 5 is a matrix of size dimension 1 by 5. That's one row, 5 columns. For example, if you let W equals zeros, 2, 2, you get a matrix. And then you could say W 1, 1 equals 3. W 1, 2 equals 4. W row 2, column 1 equals 7. W row 2, column 2 equals minus 1. All right, this is a matrix, 2 by 2 matrix. It's a two-dimensional array. And later on in the course, we'll learn how to multiply matrices. So W times W, and this is what you get. You can even raise a matrix to higher powers. So it's a little more complicated than simply cubing each term. We'll see later on. For now, though, what we have is a 1 by 5, so that's one row and 5 columns. You can also say x equals zeros, 5 by 1. So that would be a 5 by 1 matrix, which is 5 rows, 1 column. Try something like y equals zeros, 5, and that assumes that's a 5 by 5 matrix. So you definitely need the 1 there. All right, so let's go back to our array. So once we say x equals zeros, 1, 5, we can say nice things like this: x of 1 equals 2. X of 3 equals 6. Notice this is the first element of the array, second, third, fourth, and fifth. So x of 5 equals 2 equals 3. All right, once you have an array, you can make new arrays. So we can say z, redefine z equals 3 plus x. So it added 3 to everything. And then you could say y equals z minus x. Oh, no surprise there. X times x. Well, that's an error. Can't do that because it thinks you're trying to do matrix multiplication, which we will learn about later. But this works. We're using the star dot x. So the star dot x basically is called a pointwise operator, and it will multiply x by itself component-wise. So, for example, you look at z. Let's say we want to construct a new matrix where we're going to square each of these elements. So let's say Q equals Z dot square. Okay, so that squares each element. And now let's say we want to divide the two arrays. We can say T equals Q dot divide Z. So you need this little dot when you want to do component-wise operations on arrays. Okay, so one interesting thing to recall about Octave is you can say something like x equals 1, 0.01, 4, semicolon. And if you see what x is, well, let's try it this way. So x is 301 numbers starting at 1 and going to 4 in increments of 0.01. Let me show you a small example. Y equals 2, 0.1, 3. Well, for some reason it's giving me some trouble. Octave is full of bugs, but we'll get to the bottom of this in a second. Alright, so let's go back here. Let's combine a for loop and an array. So we say y, it's giving us trouble viewing it, but there's a better way. So what is the length of y? 11. Okay, so let's write a little program that will go through this list, this array, and display every element in the array. So y equals 2, 0.01, 4. Okay, we defined an array with a lot of numbers starting at 2, going to 4, increments of 0.01. Okay, so let's let n equal the length of y. We don't know exactly how many numbers are there. We could figure it out, but let's do it the easy way. So n is the length of y. Okay. 4 I equals 1 to n. Display y of I, the ith element of the array y, and 4. All right, let's run it. So, for some reason, when it gets to well, it seems to crash for some reason. As I said, Octave is a bit buggy, but this is the idea. These are all the numbers in the list. So it goes to 4. Okay. So remember, an array is a list of numbers. And the nice thing about arrays is you can go through them and do things with a for loop. So let's construct an array using a for loop, and why don't we construct an array with random numbers. So let's let n equal 100, and let's declare an array. You have to declare it to reserve memory space. So y is equal to zeros, 1, and now if you go to the notes, search for random. There should be a random numbers here. I believe it's in these notes. Back to the beginning. Oh, perhaps they're not in these notes, so I'll have to just review. Okay, so random that's a random number between 0 and 1. Notice every time you do that, it gives you a random number between 0 and 1. Rand I, 1 to 10. Rand I. So if you do rand I, the number 5, as you can see, it gives you a random number from 1 to 5. This seems to give you a matrix. So rand I will give us a random integer. So let's try something like this. Y is equal to rand I of 10. So it's going to be a random number from 1 to 10. And sorry, there's a little mistake here. Y of I. Right, so we're going to fill up our array with random numbers from 1 to 10. And there's 100 numbers. So let's first go through this list and display everything in the list. So let's display. Let's go through the list and display. Let's give it a try. Looks like it's hard to read what's happening here. Let me make n a little smaller, just so that we can see what's going on. So I'm making n 5. Let's try that out. So this is our array. It has 5 numbers, and they're randomly generated between 1 and 10. In fact, we could do this multiple times like this. Nested loop. J equals 1 to 20. Right, nested loops. So we're going to do this whole process 20 times, but actually I put it around the wrong part, so I want to put it here. So let's do this, watch. Put it up right over here. Put J equals 1 to 20. then all of this would be in the for loop, the main for loop. So this matches up line 16, matches up line 6. And each time we finish, let's print display done and iteration, so that we know we're progressing through the main J for loop. As you can see, each time it does an iteration, it generates 5 new random numbers. Now, let's get rid of this loop here. And let's get rid of that. Let's make n 1,000. Let's do something different now. Let's not display it. Why don't we average? Let's average our array, the numbers in our array, and see what we get. S equals 0. Let's add everything up. So let's add up the elements in the array. S equals S plus Y of I. Pay special attention to this. We're going through the array and adding up the contents of the array, storing it in the variable S. And then, to get the average, so we lost the outer loop, so we can undent. So we can, let's display the average. Display average is display S divided by n. Right, there's n numbers in the list. All right, let's try it out. So if we take 1,000 random numbers and average them, we get 5.6. So let's try it again. We should get a different number. See? This is the law of averages here. In fact, let's try 10,000. It's a little slower. As you can see, it's a little slower. One way you could speed it up is you could simply try this. See, we can do something like mean. See, mean of y. So watch this. See if it's any faster. Display. Doesn't seem to be any faster. What's slow is putting this into Octave. What's slow is putting the random numbers into the array. So that's what seems to be slow. All right. So this is the basic review of Octave for Calc 1